of MPMA Plastech Month 2025, and today's theme is Advancements in Material Innovation. My name is Francis and I'm your MC for this morning. Before we begin, I would like to invite everyone to watch a short video introducing MPMA Plastech Month 2025. Can we have the video?
I would like to take this opportunity to congratulate MPMA for organizing this conference, which will highlight the latest development in the plastic industry, covering various topics such as circular economy, recycling trend and technologies, and smart manufacturing.
This is how we do the measurement of the true or part. And I believe in this plastic industry, we also have a lot of dimensions that we need to check.
Thank you. Now let me run through the etiquette for the webinar today. You would notice that we have muted and turned off video for all participants. This is to ensure no disruptions to the speakers throughout the webinar. Participants may ask or post questions related to the presentations in the Q&A box during the webinar. The speakers will only answer questions that are clearly written and based on the presentations. Kindly refrain from marketing your goods or services in the Q&A box. Kindly also refrain from posting comments or remarks to questions posted in the Q&A box. The Q&A box is only for queries related to the presentations. The organizer reserves the right to remove participants who run afoul of the webinar etiquette. The MPMA Plastech Month 2025 is brought to you by MPMA with the generous support of sponsors from or related to the Malaysian plastics industry. Please allow me to thank all our sponsors. Gold sponsor, Petronas Chemicals Group Berhad. Silver sponsors, Alliance Bank Malaysia Berhad, Arbor Sendirian Berhad, Control Union Malaysia Sendirian Berhad, Clarion Singapore Private Limited, Data Color Asia Pacific Hong Kong Limited, Angle, Exxon Mobil Chemical Malaysia Sendirian Berhad, Fang Sheng Machinery Company Limited, Haiten Hua Yuan Singapore Private Limited, Kohli Printing and Converting Machines Private Limited, Monitor ERP System Southeast Asia, Tedrick Machinery Company Limited, and our other sponsors include Kampaf Jagenberg Group, Reifenhauser Asia Pacific Company Limited. Thank you to all sponsors for making the MPMA Plastech Month 2025 a reality. We would like to also thank Malaysia External Trade Development Corporation MATRADE and the Ministry of Housing and Local Government, otherwise known as KPKT, for participating and speaking at MPMA Plastech Month 2025. Now, before I introduce the moderator, can I invite the moderator and all the speakers to put on your video so that we can take a group photograph. Secretariat, please also put on your video for a group shot. Inche Abdul Q, are you there? Okay. Mr. Chan, Punita, can you also put on? Sujata, can you see everybody? All the speakers and the moderator? Okay, let's all smile for the camera while Sujata takes a shot. Okay, thanks, Sujata. And with that, and without further ado, let me introduce our moderator for today. Our moderator, Mr. Alan Chong, is in his 27th year with Tech Scam Materials and started as a sales executive after graduating with a bachelor's degree in chemistry from National University of Malaysia. Throughout his 27-year career, he has developed a proven record of success in tech scam. He has held various portfolios in the company such as commercial sales role, lead in new business development, supply chain management, and key account management covering diverse industries such as plastics, PVC, coatings and ink, adhesives, rubber and latex dipping, food industry, and etc. Today, Mr. Alan Chong is the Deputy Managing Director of Tech Scam Materials Sendirian Berhad, which is a subsidiary of Tech Scam Resources Berhad, a company with a 52-year history in Malaysia. Mr. Alan Chong is a member of the MPMA Central Committee. And with this, Mr. Alan, I now pass the session over to you.
Thank you, Francis. Good morning, ladies and gentlemen. Welcome to the second section of MPMA Plastech Month 2025. Today, we are focusing on material for tomorrow usage by the industry players. Raw materials are significant to the plastic industry because they are the fundamental building block that determine the plastic property, cost, and overall performance. They are also the lifeblood of the supply chain, essential for the productions, innovation, and creating anything from every item to specialized industrial components. The strategic management of this material is key to the industry growth and its ability to adapt global challenges such as sustainability demands. In this respect of our schedule for this morning, from the first speaker, he will present a material from Petronas that dramatically improve the mechanical, electrical, barrier property of both virgin and recycled plastic, creating more durable and high-performance materials. From the second speaker, a series of performance polymer from Science Core with a focus of its usage in the e-mobility and how it supports electric powertrain for transportation, and this includes electric power vehicle. From our last speaker, third speaker, he will present a sustainable material that provides an option for a company to explore how to reduce a product environment impact. Okay, without any further delay, it gives me a great pleasure to introduce our first speaker for the morning sections. Dr. Samsul Farid Samsudin is a principal scientist for Petronas in the Advanced Material Group, Petronas Research. He is a PhD holder in polymer engineering from University Science Malaysia. He has 20 years of combined experience in the polymer industry and composites research with a solid background in polymer modification, formulation development, and material performance testing. Currently serves as the lead researcher for the advanced coating material research, which include graphene-based nano coating, cell healing, and thermal insulation coating. Welcome, Dr. Samsul. Can you please begin your presentations? Thank you.
All right. Thank you, Mr. Allen, for your kind introduction. Okay, let me get my slide here. Okay, all right. First of all, again, thank you to Mr. Allen for your kind introduction. And again, I am Shamsul from Petronas. And for today sharing session, I am pleased to share our topic related to graphene in a polymer and the application. Okay, as a start, allow me to give a brief introduction about what is a graphene material all about. Graphene, as we know, is a carbon-based material. As you can see here in terms of the color, let me get my there's a pointer here. In terms of color, it is the same like carbon black materials. But the beauty about this graphene is in terms of the structure. Graphene, theoretically, we normally explain it as a single layer of carbon atom that can arrange in the hexagonal structure. And from this graphene, with this flake type of structure or very thin sheet structure, it can be categorized into these two type of product. The first one, we call it as a graphene, where the purity of carbon more than 98%. And the other one, we call it as a graphene oxide, where in the structure of this carbon, it has a few functional group where it has a hydroxyl, oxygen, and also carboxylics. And if we see through the microscope or SEM, the structure of the graphene is looks like very thin layer, and single layer of graphene, we can see it very transparent, and in terms of the thickness, it below than 1 nanometer. And in terms of the performance of the graphene, yes, in terms of the future in the paper or technical journal, it always mentioned that the graphene, it has a few different properties, like very good in terms of the mechanical performance, thermal conductivity, the electrical conductivity, lubrication, and also the barrier performance. But again, the commercial value of graphene is reside in how we blend it with different type of polymer, and then what sort of properties that we are looking for. It is same like if I can give the analogy like a diamond. Diamond is expensive material, but the value of diamond will be different if we put it at a different place. Example, if we place it on a ring, the price will be much, much higher. So same goes to graphene. If we know how to blend it well in the polymer, then we can get the benefit of the graphene to improve certain properties. And talk about our graphene, Petronas has our own capability in producing our own graphene. We have the technology, we call it as CTG, coke to graphene, where we produce our graphene from our refinery petroleum coke. So as we know, this petroleum coke considered as a waste material. We have quite abundant of this refinery coke in our refinery plant in Malacca, in Turkey, Terengganu. So the amount or the volume of the refinery coke is around more than 450 kiloton per annum. And the technology that we are doing now, we're converting this coke, this waste into a valuable product, into a graphene, where we can sell it at a different price. For the coke one, normally the price of the coke is around $200 per ton. So when we convert it into graphene, then we can make it more value, generate more income with special type of additive. And the beauty about this technology for this graphene synthesis, we have this patented technology where we have produced our graphene using this kind of modular reactor. And the good thing about this modular reactor that we developed is it uses 70% less energy as compared to the conventional technology outside, where it requires very high in terms of the temperature to convert this petroleum coke or graphite into a graphene. And we also have a technical capability in terms of to produce this graphene as an additive for different applications. where at this moment, the target application for our graphene is for battery, coating, and also polymer composite. And this is how it looks like our petroleum coke. It contains of most of the composition is carbon, is around 86%, and the rest is all the impurity like nitrogen, hydrogen, and sulfur. And if we compare in terms of the technology, when we want to produce this graphene, normally people will take the source of graphene from graphite. Graphite we consider as a highly organized carbon, which means that it's easy to process, to convert it into a graphene. But if we mention about this petroleum coke in terms of the structure, is quite amorphous. It has like turbostratic carbon, so it means that it requires kind of the heat treatment, and normally, as I mentioned before, it requires higher temperature to get it crystalline or to improve the crystallinity of the carbon. And normally, people will use the temperature around 2,500 to 3,000 degrees Celsius. But for our case, by using our technology, we're able to convert this petroleum coke at much lower temperature below than 1,000 degrees Celsius. And this is how it looks like our reactor here. We consider as a modular reactor with the capacity for one reactor is around 100 grams of graphene. And we have consistently produced this graphene since 2018. And the way we monitor in terms of the quality of graphene using this Raman spectroscopy technique, where we look into this 2D peak here that I highlighted in this arrow line. So from this study, we can see it quite consistent in terms of the quality of graphene that we produce from our lab here since 2018 until 2022. And for the poor type of graphene, normally in terms of the 2D peak here is very low. All right. And for the graphene additive, we have carried out a few approach before we producing this additive in terms of selection of graphene and also in terms of the process. As you can see from this table here, there's a different type of graphene with a different in terms of the thickness and also the lateral size. So it play important parameter when we want to select the graphene to make it as an additive. And from this, we can see we have a different thickness of graphene, lateral size, and also the surface area. And from this graphene, we do kind of screening. We put a graphene in a certain type of solvent, and then we do kind of the sonication using ultrasonic bath at certain temperature and hours. And after that, we do a screening to monitor the performance of graphene, whether how easy the graphene particle to exfoliate. Normally, if the graphene gives a very good in terms of quality, it easily to exfoliate and disperse well in the solvent. So this is what we have carried out in our lab. After we exfoliate, we use this sonication process. Then we leave it for 3 days, and then we monitor again how good the dispersion of graphene in the solvent. And from there, we can see here for the poor type of graphene, there's kind of the sedimentation happen. And for the good graphene, because of the good in terms of the exfoliation of the graphene particle, graphene layer, it can stabilize for a longer period of time. And in overall, in terms of the performance of the graphene in the polymer, again, it depends on how we select the graphene type in terms of the morphology, the lateral size, whether the graphene, we need to do kind of treatment functionalization to improve the compatibility between the particle with the matrix. And in terms of the selection of polymer, we need to understand as well in terms of the MI of the polymer, whether the MI is good or sufficient to blend with this graphene particle, and whether we add in other type of filler, because if we add in other type of filler, we also need to consider in terms of the size. Because if we choose the wrong size of graphene, it may result that the graphene would not perform as what we expected. And other than that is in terms of the mixing method, how well we mix the graphene particle in the polymer. Example, if we want to mix this graphene particle in the thermoplastic, we need to understand in terms whether we require to do a kind of the pre-mixing to get the graphene dispersed first in the powder form of the polymer or in the pellet form, and after that we will add into extruder for the matte blending process. And this example, how we carry out kind of study. We blend the graphene powder with the HDPE resin. But before we do this blending, we do some treatment in this graphene. We put it in the solvent to prepare as a master batch. And we will let the graphene to exfoliate first and then disperse well in the graphene, in the HDPE pellet. And after that, we conduct the matte blending using internal mixer. We control a certain temperature, for this case, around 190 to 200 degrees Celsius at a screw speed of 50 RPM. And even this compound, in terms of the volume, is very small, it's around 50 grams. But in terms of the mixing, we can see there is an improvement in terms of the dispersion of graphene using this matte blending technique. So from here, we make it into a thin film for different type of testing and characterization. And this is one of the example we characterize in terms of the dispersion of graphene at 0.01 weight%, where we study different type of graphene here. We put it the label as G1, G2, G3, where G1 has a very fine in terms of the morphology, the size, and G3 one is a bit coarser. And this is what we see after we do the matte blending, make it into a thin film at around 250 micron. Then from the microscope, we can see the dispersion of graphene. So for the G1, the final grade of graphene, we almost can't see any graphene dispersion here, because we believe that because of the finer size of the graphene, it blends well, it disperses well. So we only can see very small dot of black color here, the black graphene. And for the G2 and G3, we notice that the dispersion here of the graphene is good, but we can see in terms of the particle, we can see the big particle around scattered around this film, and some of them is quite a big size of particle. So we believe by having this coarser in terms of the graphene layer or thickness, it also will affect in terms of the dispersion of graphene in the polymer film or HDPE. And if we want to focusing on this graphene as a barrier additive for water and gas, graphene definitely has been widely studied as a new additive for a barrier performance, especially for the coating, because it has very good in terms of hydrophobic in terms of the future, and it has very thin layer structure with higher aspect ratio. And from this diagram here, we can compare how different in terms of the graphene flake with other type of the additive or filler with the same flake structure. As an example here, if we take here example for the silica or for glass flake, the size, some of the size in the micron level, so it also can give barrier performance. But when we add graphene, it will further improve in terms of the tortuosity, where it will slow down in terms of the gas or water to penetrate from this substrate, the film of the HDPE, to the product or to the main substrate that contact with the polymer. So this is the beauty about graphene, the function of graphene as a barrier. It will slow down further the diffusion of gas or oxygen. And we go detail in terms of how we study in terms of the performance of the graphene as a barrier here. with the film with the thickness of 250 micron for the HDPE. We study at different grade of graphene, the finer one and with the coarser one. And from here, we notice the improvement for the finer graphene G1 is about 45% as compared to the control HDPE. And from this G1, we further explore how is the effect of the loading of graphene to this WVTR performance. And from here, we notice that when we add it more loading of graphene, it will not show any improvement for the water vapor transmission as compared to 0.01 weight%. So we believe that when we further increase in terms of amount of graphene, it will create kind of the agglomeration, and from there it will disrupt the laminar structure of the graphene in the film or in the polymer. And what we can highlight here in terms of the loading of graphene that we use is very, very small. For this case, it's only 0.01. And maybe in thermoplastic industry or other type of coating, in terms of to improve the barrier performance, they require quite a number or high loading of the additive. Some of the cases that we study that published in a journal, some of the additive, the master batch, they use up to 5 weight%. And as compared to with this graphene, we use very minimum, less than 0.1 weight%, which only 0.01. So means that it can give benefit in terms of reduction of the additive later if we use this graphene. And other than these barrier properties, we also evaluate in terms of how this graphene affect in terms of the crystallinity of the polymer. For this case, we evaluate on the HDPE at the different type of graphene, G1, G2, and G3. And we notice from this study, with G1 finer grade of graphene, it can further improve in terms of the degree of crystallinity. And it proved that from this work, graphene also can act as a nucleating agent to improve the crystallinity structure of the polymer. And from there, it will improve further for the other properties like a barrier and also for other mechanical properties. And this another study that we want to highlight here, where we use graphene to study how the graphene effect in terms of the UV stability of the HDPE film. We put this film that we blend with graphene at 0.01 weight% in the QUV chamber, and then we monitor for 1 week, and then we study in terms of the mechanical performance and also the carbonate index. And from here, we can observe without graphene particle, we can see the reduction in terms of the tensile strength from this 17 to 7 megapascal. But for the one that we add the graphene at 0.01 weight%, it is quite stable, up to 336 hours of UV, more than 2 weeks. And in terms of the carbonate index, because we need to understand further, other than this tensile strength, whether the graphene really improve in terms of the UV stability by checking in terms of the carbonate index, because this carbonate index from this FTIR, it will explain to us how big in terms of the changes of the HDPE chain, the polymer change when it degrades. Normally, when polymer degrade for like HDPE material, it will introduce kind of the carbonyl functional group. And here, it's evident that for HDPE sample, after we expose for 168 hours, we can see there is increment in terms of the carbonyl index, the carbonyl functional group. While for the HDPE one, in terms of the increment is quite small, and compared with this HDPE and HDPE with graphene is about 2 times lower. So it is proof that here graphene also can be potentially used as a UV stabilizer for the polymer. And other than that, we explore potential use of graphene in a mechanical performance of the polymer. For this one, we share different type of polymer. Example here, we add graphene in this graphene epoxy for hydrogen tank, where it can further improve in terms of the pressure before it bursts when we add graphene in this epoxy composite. For this one, it's different type of composite, flat polyester. Also, it show the improvement for the fracture strength and also fracture modulus more than 30%. And for the PP materials here, and by adding the graphene at certain loading less than 1%, it improves the performance of the fracture strength and modulus by 20%. And we can see there is other potential application of graphene, not only to improve mechanical barrier, thermal, and also for the UV. It also can further explore to see how this graphene to improve in terms of the shrinkage and warpage issue in the thermoplastic molding product, and as well for the anti-static application, because we believe that the graphene with very minimum in term of the loading, it can give very good in term of the heat dissipation, and it can uniformly distribute in the polymer. And graphene particle also can give kind of good interfacial interaction with the polymer, and it will hold the movement of polymer chain and maintain the dimension of the molded product. And as for the aesthetic, definitely graphene gives very good in terms of the conductivity at certain loading. Example, for this case, 1 to 3 weight% can further improve in terms of the conductivity of the polymer, and from there it can give very good as a permanent anti-static additive in the film. And the target application for this anti-static mainly for the packaging film and also electronic device material. Okay, now we come to the end of this presentation. As a summary, that what I can highlight it here, graphene is very good. It can give a very good performance in a thermoplastic to improve certain mechanical performance, barrier, and also act as a UV additive. And we also need to establish in terms of the right blending technique to ensure the graphene that we add into the polymer has a good in terms of the dispersion, and it can function as what we expected. And not only to improve in terms of the performance, the physical or mechanical performance, but we can say that by introducing graphene in a polymer, it can further improve in terms of the material consumption, because at certain application we can reduce in terms of the thickness of the polymer, thickness of the film, or reduce number of layer. And at certain point, we can also use graphene as an alternative additive to replace the existing special additive, where we know that for some of the special additive, it requires quite high in terms of the loading, more than 5 weight% or 6 weight%. And by introducing graphene, we can further reduce it just below than 0.1 weight%, and it can perform similar as a normal additive that currently being used in the market. All right, I think that's all from me, and thank you very much for your attention. And I pass it back to our MC, Mr. Allen. Over to you, Mr. Allen. Thank you.
Thank you, Dr. Samsu. I think you have made an interesting presentation, and also graphene seem to be a robust product, for compounding process to improve many aspects of the performance of the polymers. Okay, I think we have some question posted in the chat box. The first one is can Petronas work with biochar as a feedstock for e-graphene technology?
Yes, the answer is yes. We are open for collaboration. And if you need to have further discussion, we can start a discussion to explore how this graphene can be used for the biochar.
The second question is how does the barrier compare to EVOH?
Okay, it's very good question. For this one, we haven't conduct a detailed study for the EVOH because we understand that the EVOH material has unique in terms of the structure of the polymer that can improve in terms of the barrier because of the crystallinity of the EVOH and the functional group. But we believe that if we add in this additive, this graphene into EVOH, it can further enhance the performance of the EVOH as a barrier material. And as I share in the slide, maybe we can take this opportunity to further reduce in terms of the amount of material used as a film. All right.
Okay, refer to third questions. Saying graphene has strong potential to improve mechanical and barrier property, what are the main factors limiting its performance in polymer-based geocomposite, whether is it dispersion, interfacial, bonding, or cost?
Okay. In terms of the application in the polymer, the limitation, what I can understand when we do kind of the sharing session with industry, the main feedback that we receive is in terms of the cost. But we have to understand that even the cost of the graphene, example here, 1 kilogram of graphene, the price can be around 100 to 150 USD. But the loading that we add into the polymer is very small. As we have conduct some study here for thermoplastic, the loading of graphene maybe less than 0.1%. That part, we need to go details and how we get it balanced in terms of the performance and then reducing in terms of the total material use and also the cost. At certain point, we can also say that by introducing graphene, example, the one that we have developed with several pen manufacturers, we add graphene and then from there it can enhance in terms of the barrier performance and we can give kind of higher warranty in terms of the service life of the pen. So means that when we talk about the service life of the pen, we can extend in terms of the warranty. So means that in terms of the cycle for the operation to replace the material with the new one will be lower and it will cut the cost of the operation. So we have to make it balance in terms of the performance and also the cost at the end.
Okay. The fourth question is any plan to have LL or LDPE as carrier?
Okay, good question. As a carrier, definitely, because for this graphene, the best technique to disperse the graphene in the polymer, we should make it into a master batch form at a higher content like 5%, 8%, or 10%. And after that, we need to dilute it into the final product to get it dispersed well. Because graphene that we add into the product is very small amount, less than 1%, 0.1%. If we use it in a powder form, it's not easily controlled in the extruder. Sometimes maybe we cannot get exact amount or loading of concentration graphene in the end product. So that's why when we propose the approach to use a master batch of graphene, so LDPE and LDPE is the right material that we can say to be used as a carrier for the master batch. But there's one we need to discuss what is the end application and then what is the target performance that we are looking for.
Okay.
Alright.
Thank you. Francis, there's 3 more questions. I'm not sure whether do we have time constraint.
I think we
To
can
go
proceed
through
with the
all?
3 questions, Alan. Go
Okay,
ahead. The 3
okay,
questions. Well
yeah.
done, Alan.
Yeah, so the next question is it possible to use a medical device like syringe? It will affect the transparency of the PP?
Okay. The transparency of the PP is depend on amount of graphene that we add in. Example, for this case, when we add the graphene at 0.01%, it didn't really affect the transparency of the graphene. And also depend on type of graphene that we are using. Final grade of graphene, we call as a premium type of graphene. It will not affect definitely, but coarser type of graphene, even at 0.01, it may impact in terms of the transparency. Yeah. Again, this depends on the morphology that we selected.
The next is what is the regulatory compliance status of graphene?
In terms of regulatory, I believe you're referring to for packaging, food packaging, FDA and so on. Based on literature, I didn't see any limitation for this graphene to be used in different type of packaging. Other than that, I have no idea. Maybe I need to go through again in terms of what the special regulation to add graphene for this certain application. But for different type of industry like coating and composite, so far there's no any special regulation or limitation to add graphene in the final product.
Next is any plan to produce graphene pre-brand grade in BrefChem or PEM?
Okay, that's one. So far, we haven't do any detailed discussion about producing own graphene material from the BrefChem product. But at this moment, the business that the approach that we carry out now is to producing graphene master batch that can be added into a polymer composite and also coating. If you are interested to use this kind of the graphene master batch for your product, please let us know. Please contact me. Then we can have a further discussion how to make it work. All right.
Can graphene used in PVC application? What dosage would you advise?
Okay. For PVC, I believe it is will be the same as a normal type of polymer. Yes, we can add in graphene. We can start at very low loading, 0.1, 0.01, 0.05, and 0.1%. And it depends what kind of the properties that you are looking for. If you want to improve the mechanical, then maybe we can play around with different loading of graphene. That part, definitely, we need to have kind of the product development. And again, if you are interested, then we can also partner together with Petronas to develop a special graphene for your product.
Okay, next is how best can you improve on the color of master batch?
Color. Color, are you referring to the master batch color, the white color, or other different type of color? For other different type of color, I don't see any issue because the amount of graphene that we add in very small. It may not affect the pigmentation or color of the master batch. But if we talk about the white master batch using a DiO2, and definitely add in the graphene, it will change a bit the color of the master batch to gray color, gray type of color. Yeah.
Okay, I think one last question is beside better mechanical property, can it extend to property of odor control and antibacterial benefit?
Okay. Good question. So that's why that I highlighted in my last slide here in terms of the performance of graphene for different application. And when you ask about this antimicrobial, there is a study made by other researchers, and it proved that this graphene can be applied as well as antimicrobial additive because of the graphene, especially GO, graphene oxide. It has a few functional group, and this functional group can inhibit the formation of the microbe on the surface of the substrate. But for the other function for this graphene, we didn't make any detailed study about this function, the other function. But I believe we can explore further to see the potential, because graphene is quite flexible in terms of the material, because we can further modify the graphene with different functional group to make it work for different application. That's the beauty about graphene.
Okay, I think Dr. Samsul, based on time limitation, there is
All
few
right.
more questions in the checkbox. Well,
Okay.
later you can answer it through the checkbox. I think.
All right.
That's
All right. Sure.
one way. Yeah. Francis, you have any comment?
No, I just want to say, yeah, there's a lot of questions.
Yeah.
I'd like to thank the audience for all their questions, but yeah, because we are time sensitive, we have to move on to the next presenter. Thank you, Alan. Well done, Alan. Thank you.
All
Move
right.
on to the next presenter, Alan. Thank you, Doctor.
Yeah.
Thank you, everyone.
Okay.
Thank you for your interest.
Allow me to introduce the second speaker, Mr. Yasunobu Sato, the Regional Business Development Manager for the transport business in Asia Pacific region as Sysco Specialty Polymer Japan, or formerly is a part of Solvay Group. Prior to his current position, Mr. Sato served as a global marketing manager and previously as a sales development manager and research scientist at Solvay Specialty Polymer since 2011. From 2008 to 2011, he was a senior research scientist at Manabit Incorporation, a joint venture between Chiso Corporation and Kobe University. Earlier in his career, Mr. Sato was a special postdoctoral researcher at RIKEN, working under Professor Mizuo Miyata in the Laboratory of Bioengineering. He earned his doctorate from Keio University in 2004 under supervision of Professor Haruma Kawaguchi in the Laboratory of Polymer Chemistry. That is a short introduction about Sato-san. Sato-san, you can proceed with your presentation.
Thank you very much, Mr. Alan, for chairing this session and introducing me myself. I'm Yasunobu Sato, and today I will be giving a talk on high-performance polymers in e-mobility. So, and also to start with, I will kind of introduce our current company, which has changed a bit from the past. Okay, so let me begin with a brief introduction to Syensqo. As you may know, Solvay, which is a Belgian chemical company, end of 2023, we separated into two independent entities. Syensqo currently has actually 4 global business units, one of which focuses on specialty polymers, such as fluoropolymers and high-performance plastics. And this is the GBU which I belong to. There are other GBUs such as composite materials and surface chemistry solutions and extraction reagents. But these are all 4 GBUs under Syensqo right now. The essential chemical side still continues to use Solvay as a name. So the soda ash, peroxide, and silica part, those are currently run by Solvay. Anyway, the specialty part of chemistry all are now currently under Syensqo. We have about 13,200 employees across 62 industrial sites with 6.6 billion net sales. Importantly, our product portfolio and product brand names remain unchanged, ensuring a continuity for our partners and customers. Our specialty polymers business leverages decades of expertise in polymer chemistry, process engineering, and application development, supporting customers from concept to commercialization. Syensqo is a global leader in high-performance materials. We are number 1 in high-performance polymers, thermoplastic composites, and also lead in materials for civil aerospace and defense. Materials business represents about 60% of the total sales. And the remainder goes to the consumer and resource type of chemical substances. This leadership is built upon innovation, quality, and the deep understanding of our customer needs. Our R&D investments focus on next generation polymers with enhanced thermal, mechanical, and electrical properties. So that's what we kind of focus as a company. As the science goes, sustainability is also at the core of our strategy. Our One Planet goal includes achieving carbon neutrality by 2040, and also ensuring 18% of our sales which come from circular products by 2030. We are also committed to safety, diversity as well. So for our partners in Malaysia, this means you can rely on ScienceCo for sustainable, future-ready solutions. We are actively developing polymers with recycled and bio-based content, and optimizing our manufacturing processes to minimize environmental impact, meaning decreasing the carbon dioxide as much as possible. So, of course, sustainability is one big core which we also implement in our strategy right now. So from here, I will focus my talk on specialty polymers for transportation market, which I am responsible of. We will see a shift in interest to high performance materials. But before talking about the polymers itself, I would like to kind of briefly update you about the market of transportation. Let's look at the global powertrain market first. This kind of graph shows you the number of vehicles in different powertrains, which is made up of. As you can see from the right top corner, I've wrote XEV. This includes battery electric vehicles, plug-in hybrids, and full hybrid vehicles. These will account around 60% of the market in 2032. Of course, as you know, hybrids, they contain engines. So internal combustion engines, they continue to decline, but actually 65% of the vehicles will still have some kind of engine, often with improved efficiency. Anyway, this transition to e-mobility is driving demand for advanced materials that can meet new performance, safety, and also sustainability requirements. E-mobility introduces higher voltage systems, such as 400. Maybe you also hear a lot about 800 volts now. Increased power densities and stricter thermal management needs, and all of which require materials with superior electrical insulation, thermal conductivity, and flame retardance. So this is the trend of the powertrain market itself. And from here, we will look into what kind of architecture is needed for e-mobility. E-mobility is transforming vehicle architecture into three main components, which are called very essential. And these are the three: e-axle, batteries, and power electronics. The e-axle part kind of compromises from two main components, which is the e-motor, e-drive, or it's kind of like an electronic transmission or gear set. This is called the e-axle. We need to improve e-motor power so that you can make the motor smaller and efficient. In these cases, you need to allow faster RPMs, that's the rotation itself. And to do that, a lot of material or components which are written here needs a kind of upgrade from also a material standpoint of view, which I will explain later in the detailed session part. In the middle, of course, if it's an EV, you need definitely batteries, the increase in power density, improvement in heat transfer by enabling integrated design, and also manufacturing batteries with a low binder concentration. These all things all kind of relate to what the improvement is needed in the battery area as well. And also you might have hear a lot about batteries kind of under fire. So nowadays there are a lot of requirements on how to make the battery safe as much as possible, allowing materials needs such as flame retardant polymers, low smoke, low toxicity kind of polymers are needed for battery housing itself. And last but not least, about the power electronics. This is more likely the semiconductor part, which is used for inverters. Power density, faster switching, and the heat dissipation is very much needed. And in these cases, a kind of upgraded material is always asked to make the most advanced system in this area. So these are kind of the components which are needed. And if we see here on the left-hand side, I've shown the internal combustion engine, and on the right-hand side, the XEV. There are some differences, as you can see from the change you will be able to see from internal combustion into XEV. But a lot of materials continue to be used, such as the high-performance materials, which I will introduce, which Syensqo handles, continue to be used even in the e-mobility area itself. So we think that the trend of change in e-mobility will also continue to ask more and high-performance polymers, which can be used in the coming decades for the next generation XEVs itself as well. So that's kind of the trend I wanted to kind of start with. And from here, I will kind of introduce you what actually Syensqo has for these applications itself. To start with, I think I will kind of dive into our specialty polymers portfolio. This is kind of the plastic portfolio pyramid I think you will see a lot. Syensqo actually handles the high-end type. We actually do not handle commodity polymers, but we specialize in specialty polymers sector. So from the left, you can see sulfone polymers. On the right top, you see ultra polymers, such as polyether ether ketone, one of the best polymer materials you can find. We go to the left, we also have fluoropolymers. We are definitely very strong in the fluoro industry. So we have, for example, PVDF, heavily used in batteries as well. On the left bottom, we see aromatic polymers, PPA, which is a high temperature nylon. PPS is heavily used for power electronics. I mean, it's a very low moisture absorption polymer itself. LCP, which kind of flows very well in electronics, and para, which is a MXD6 nylon. So these polymers we all manufacture by ourselves, and we make compounds and sell to our customers, and the molders especially mold it from the design spec needs from the tier ones. Other than that, maybe on the right-hand side, these are not plastic, but we also are very strong in fluoro liquids, PFPE, which is kind of used in fluoro grease, and also liquids that needs to be used for manufacturing semiconductors. And fluoroelastomers, which is used in seals. These things continue to be used even in the e-mobility sector. And we have a broad portfolio range which we can support our customers. So this remains unchanged, and we continue to promote our material to our customers. Now, on top of the specialty polymers portfolio, I mentioned that sustainability is not a compromise for us. We have a new portfolio. We called it ECO, which integrates bio-based and recycled content into high-performance polymers, ensuring low carbon footprint without sacrificing technical performance. So we are now kind of generating a portfolio of existing material to an eco portfolio. So if you need sustainable material from the point of bio-based content or recycled content, please contact us. We will be able to kind of give you some suggestions needed for the future sustainable portfolio, which you might need to use to overcome some regulations. So that's one part which we continue to do to kind of upgrade our whole polymer portfolio. Now, from here, I think I would like to explore how our polymers are used directly in the e-mobility system. So you will get an image on where our high-end polymers are used. To start with, the biggest, I think, area in e-mobility will be e-motors. So this is a motor, and it actually, rotates the wheels by electricity. So e-motors require materials that can withstand high temperature, electrical stress, and mechanical loads. For example, magnet wires, which is written here, polyether ether ketone can provide exceptional dielectric strength, thermal endurance up to 240 degrees, and chemical resistance. And these materials are very highlighted very much now in the market. A lot of insulation, electrical insulation is needed in these systems. So you will also see a lot of polymer films. And Syensqo actually has a film manufacturing capability. And we have a brand called Agedium to make plastic films. And these plastic films can be used as slot liners in the motor system as well. In the motor area, of course, there are other things such as connectors and lubrication and the rotor housing itself. I will skip that for today. But there's a lot of parts or components where Syensqo material can be a big fit. So that's where we are targeting and asking our customers whether they can use our material for their next generation e-motors. By using our material, our solutions actually deliver efficiency increase of the motor itself. By reducing the electrical insulation using our material has a very good insulation. You don't need to use a thick electrical insulation at the end, meaning you can increase copper. Now, if you can increase the copper slot fill, that means the motor efficiency increases. So these things help the designers of motors. And in these areas, I mentioned a little bit about PEEK, P-E-E-K. These things can be coated or extruded on top of copper wire, which are called magnet wires. And these approaches kind of supports the increasing efficiency of the motor itself. So efficiency increase can be achieved by using a material. And also on the right-hand side, miniaturization. At the end, you would like to make smaller motors as much as possible with a high efficiency. So in those cases, electrical insulation and thermal stability, thermal resistance is going to be important, which kind of tends to move the trend of selection of polymers from commodity to the high performance polymers. And that's where we are supporting our customers. One good example, or maybe a detailed example, is about the magnet wire insulation. Magnet wires are mainly made of copper, and there needs to be an electrical insulation on top of that. Currently, PEEK is used as a good material to do this, compared to the past varnish type of electrical insulation. So currently, direct extrusion on top of the magnet wire of the copper wire can be used to make magnet wire insulation. ScienceCo has developed a special PEEK which can directly adhere on top of copper, and this is currently being used for magnet wire production. A different application will be slot insulation. So there will be an insulation in the motor slot itself. As I mentioned, we also are a manufacturer of slot liner, so plastic films. And we have a high thermal rating plastic film and low moisture absorption plastic film, which can be used in slot liner insulation as well. So these are also areas where we see a big demand and ask from our customers to provide high performance polymer plastics. And PEEK, PPSU, which is a sulfone polymer, these films are currently delivered to our customers for their next generation e-motor design. So the first part was about e-motors. I will next go into a little bit on power electronics. The power electronics application itself is kind of squeezed into this one slide itself. It requires materials with high dielectric strength, flame retardance, high voltage, and thermal resistance as well. So applications include a very big variety of applications, such as inverter housings, onboard chargers, connectors, bus bars, which is also similar to the motor part. With the adoption of 800-volt architectures, it means a high voltage architectures for efficiency, an excellent tracking resistance, CTI, comparative tracking resistance, is normally needed. And in those cases, we have a special material such as PPA, which is a high temperature nylon, and also specialized PPS, which has a high CTI value for designing these housings and connectors, so that the creepage distance, meaning the distance between the electrodes, can be minimized as much as possible. So those materials are supporting this area as well. Again, mainly it's about how to increase efficiency and how to maintain the safety of these components. Higher dielectric strength, meaning, okay, higher electrical insulation is one big factor, and that definitely our material from ScienceCo supports that. One more thing as a trend I see is high thermal shock resistance. In the automotive industry, as you can imagine, the temperature range of the component will be in is, from very low to very high, such as minus 40, minus 50 degrees, and sometimes up to 180 in case of if it's in a kind of a motor itself. So these kind of thermal shock is always very important to resist. And for that, a specialized material is needed in the area of PPA and PPS. So high thermal shock resistant type of formulations are being continued to be developed to support those customers as well. To kind of explain a little bit in detail of these thermal shock resistant materials, such as bus bars. There's copper electrodes and the CLTE, the expansion rate is different of plastic and metal itself. So it has to resist cracking during these heat shock resistant cycle tests. And we have very specialized materials to do that by also maintaining a very high CTI so that the designer can design a bus bar with a very close creepage distance so that you can make a small bus bar as much as possible. We have that from our PPA series and PPS series, which can support those applications as well. And the power module housing itself, a little bit more difficult and very strict requirement is needed for this. But also our PPA and PPS formulations can support making power module housings in the area. The last kind of architecture I would like to explain is around the battery solutions. Now, the battery solutions, of course, I've written here kind of the broad picture as an overview. But very importantly, we are also supporting a lot inside the battery cell itself. It's more likely the cell chemistry itself. PVDF is heavily used for binders and coatings for the insulation coatings itself. So PVDF is heavily used. And we also support other things in the battery casing solutions, such as maintaining flame retardance and stopping thermal runaway. So those type of things are kind of keywords in the battery system. And we are continue to develop new grades so that we can slow down the thermal runaway and also improve the efficiency of the lithium-ion batteries itself. Same to the other architecture needs itself. Cell to pack, we make the battery. Higher energy density continues to be very important. Our PVDF material as a cathode binder helps this. So our customers continue to use our PVDF called SOREF. On the next part, I would like to kind of briefly show you that our materials are safer. We have a safe material to kind of delay the thermal runaway, which happens in battery systems. And these are mainly made by LFT, we call the long fiber type of thermoplastic. And by doing so, we can slow down and kind of protect the battery as much as possible. And there's a lot of metal components in the battery system. So a lot of discussions continues to replace metal to plastic as we go through. So SOREF PVDF used in lithium-ion batteries for the cathode binders. This is still a big area, and we will continue to see a big growth in this area as well. And a lot of bus bars, connections inside the battery itself. One keyword I think will be orange. So orange colored high performance polymers will be needed because at a high voltage usage, you need to use orange for the connections. And we have a special orange colored extrusion materials, injection moldable materials, which can support these bus bars as well. One other application I just want to explain before ending is a fuse. This is called a pyrofuse. A pyrofuse is a fuse that uses the pyro technique. The pyro technique is very similar to the airbag system. So if you kind of ignite it, there's an initiator and there's a small explosion inside this fuse. So it quickly kind of cuts off the bus bar. So this is called a pyrofuse. The pyrofuse housing itself needs to resist this small explosion happening inside the fuse itself as an initiator. So a very strong material, a very strong mechanically strong material is needed. But also, since it's a small explosion happening in this pyrofuse, you also need a flame retardant grade. Actually, there's a difficulty of making a flame retardant grade with a very high mechanical strength. Thanks to ScienceCo's R&I team, we have a very special grade for this, specifically designed for pyrofuses and fuses. And a lot of customers are currently evaluating and will be in the market in the coming years. So HFFR, flame retardant grades with high mechanical strength, is one kind of area which we see kind of growth. And if you have those applications, we can support you as well. So maybe it was a little quick in introducing my slides, but this is the final slide. Thank you for your attention. At ScienceCo, we are committed to advancing humanity by pushing boundaries of high-performance polymers in e-mobility. We have a very new website on e-mobility, and you can access it to find the solutions and find the best fit plastic which you should use in the applications as well. If you have questions, you can contact me. And thank you very much for your attention. And giving it back to Alan.
Thank you, Sato-san. Thanks for the comprehensive briefing and also learning from you about a series of high-performance polymer. So it's really eye-opening to me. Yeah. Without further delay, let's proceed to the Q&A section. So far, we have one question from the participant. The question is like this. EV battery are seeing high rate of explosion. Major cause are impurity in battery separator film. Have you got any solution?
Yeah, thank you very much for the question. I think this question is more related on why the EV batteries are currently, see some explosion itself. It's a little difficult to explain everything, I think, because there are a lot of causes of this itself. One of them, of course, as you mentioned, impurities but how to control the separator in the film, separator film itself is very important itself. A lot has been, I think, improving. That's one point, of course. The high energy batteries, I think there's a slight trend to reduce the energy density, but also make it very safe. We call it, there's an area called LFP batteries. I think is a kind of a trend right now, which mitigates a little bit on the density itself, but is more safer. So the combination of the components of the lithium-ion batteries are improving every day. So what I see is there will be, an improvement as we go through, and you will see low amount of explosions in the future. So I think there's a lot of reasons behind of what happens, but there's an improvement, and I believe that we can, from a battery cell standpoint of view, we can control it in a good way. And I hear that some battery manufacturers have a very low defect rate, which helps kind of stop almost these fires from batteries happening.
Okay. Sato-san, I have a question to
Yes.
you. It's regarding one of your product, PVDF. Based on my reading, I understand that PVDF is being used in the battery separator film productions.
Yes.
As a coating layer, right? So actually, how did PVDF help to improve the positive ion or negative ion flow in between the cell with so-called separate by the battery separator film.
Thank you very much. Actually, the main usage of PVDF itself is for the binding of the active material at the cathode or the anode itself. So the PVDF actually kind of supports these active material, and you want to include a lot of active material in the surface of these electrodes itself. So PVDF kind of links these active materials in a good way. So there are a lot of PVDF in the world, but one of the advantages of science cores PVDF itself is it efficiently links all of these active materials in a good way, and it has a good binding strength to the active material. And that is why PVDF, even though PVDF is one chemical, name, there are a lot of kind of differences in the small from the small area you can imagine. So PVDF itself and our PVDF itself has a very good binding efficiency to these active materials and also to the electrode itself, which helps the flow of the final ions.
Okay, interesting. Yeah, my second question to you is, to me, China in EV technology, especially EV car, they seem to be ahead of many countries in the world today, you know. But based on a series of the high performance polymer that you have presented, used in the EV mobility, is it your product is being widely used in China? Because I believe the supply chain for the EV industry is quite matured in China, but it's relatively new to South Asia region or maybe to Europe as well, So basically, I just would like to have a better understanding how your product is being applied, especially in China.
Thank you very much, Alan, for the question. Yeah, definitely our products are also used in China as well. The main thing which I see is for the very high-end EVs, initially, for example, the 800 volt and the 900 volt, it was kind of mainly started from Europe. So we also support a lot of European customers in that sense. So our materials are kind of used globally. It's not a kind of a local thing that we see, but the number of production of EVs, as you have mentioned, China is the kind of first runner. So our materials are continued to be used there, in China as well. And the advantages which I have mentioned are some of the values which Chinese customers or Chinese OEMs feel from our products as well. So it's not a locally specified, trend itself. China is definitely growing faster than other areas from an EV standpoint of view, but it's used everywhere. It's not just China. What we see.
Okay. Thank you very much. Is there any more question from the participant?
There's none in the Q&A box, Alan.
Oh, okay.
I think we can move on, Alan. Thank you.
Yeah. Thank you. Thank you, Sato-san, for your
Thank you very much.
presentation. Yeah, thank you. Let me introduce the third speaker.
Sato-san, can you stop share?
Yes, I will. Wait a minute. Oops.
Third speaker is Inzik Abdul Koyan Mustaqim Faye from Kaya Group of Company. Today, he is the CEO of the company. In order to simplify to call him, maybe I will start calling him Mr. Q. Mr. Q, from 2013 to 2014, he was the operation executive of Gagasan Steel Sdn Bhd, following which he was appointed to operation executive at Gaya Plus Sdn Bhd and rose through the rank to operation manager at Gaya Plus Sdn Bhd. And now he is the CEO of Gaya Group of Company. Yeah. Okay, Mr. Q, you can proceed with your presentation.
Okay, thank you very much, Mr. Allen. Before I start, a very good morning, everyone. Let me share my slides first. Okay, sorry. Let me do this. Yep. Okay. Bismillahirrahmanirrahim. Assalamualaikum and a very good morning, everyone. The name's given Abdul Qayyum Mustaqim. Thank you, Mr. Allen, for the introduction. People call me Q. It's a very short and simple name to be called. So today I would like to take this opportunity to present a bit about what this Gaya Group of Companies does. And I see many discussion today, it's towards sustainability. It is aligned with our current movement of Asia, ASEAN, where we are, Malaysia is the leader of ASEAN for this year. So we want to take this opportunity as well. So Gaya Group of Companies has been established since 2006. We've been operated mainly towards plastic packaging products. Back then, we were focusing more on plastic product, on medical products, you know, like the bottle ubat for the medicines and etc. And over the years, we find an opportunity to bump into palm oil industry. So Gaya Plus is the mother company of structure, and Gaya Green Tech today, ladies and gentlemen, as you can see, it is a subsidiary of Gaya Plus near Berhad. So today I'm presenting a bit of what does green technology we are doing. For the past many years, just to share a bit, for the past many years, we're producing almost 14 million pieces of plastics and to supply to all palm oil industry, to export market into South Africa, Middle East, and Southeast Asia. And the team, the top management, myself, and Parina, my executive chairman, had the vision that we are actually polluting the world, you know, by producing that much of plastic and supplying to around the world. And we are trying to find the alternative way on how to create value within the palm oil industry itself. So today, I would like to share with all of you what is our technology that we found, and we made it from 0 to 100% capability for all type of application. So the products and services that we do, a little bit get to know about Gaya Green Tech. Yes, it is renewable, biodegradable, and compostable. So to share about something renewable, it's a new combination of biomass. I'm sure bioplastic is not something new. It has been talked ever since many years ago, but due to our current movement towards 2030, that we want to have a more sustainability in terms of even in all the product, FMCG, plastic packaging of all, including household, industry level. So we are trying to be part of the market to give a solution with our new founded material. So we have 3 types of material that we have. Next, project sustainability about Gaya Group of Companies. As many other companies, it's very crucial to have a sustainability eco chain. So over here, I take the opportunity to share in terms of investment, strategic partnership, collaborators, and business. So there are some, we've dealt with Petronas Chemical before, and we are very close, working very close with FGV in terms of making all FGV local product into a eco-friendly packaging, which is not easy, ladies and gentlemen. I can tell you that it is not an easy journey, as when we talk about new material or new development, it's always about the cost efficient. So we are trying to work on that as much as we can. And collaborators are also important here, just to share with all of you that we are working together with all the intelligent people, with all the university. Over here you can see there's the University Kuala Lumpur, UiTM, and also University Science Malaysia, and KKTM, and many more government-related and non-government-related agency and universities. A bit of project background of us is that mainly we were focusing on non-degradable petroleum-based polymer. Gaia Plus itself, we are using almost 300 ton as an SMEs, as a mid-tier company. We use 300 ton of HDPE material to produce the plastic packaging for palm oil industry. And is a petroleum base. So it's as usual. I believe all of us in this Zoom, we understand all this thermoplastic, typical plastic, we say. So we are trying to solve this key problem that provides a high carbon footprint, and of course, the plastic waste pollution on the sea and the land. Before further view about the product, I would like to share the opportunity in the global bio-based resin market overview. This is a data that Gaia worked with Deloitte and Madrid through a program. And as you can see, ladies and gentlemen, the market has grew. The demand is growing up to 2030. We just got back from K-Fair Plastics exhibition in Germany, Düsseldorf. It's amazing to understand where the market is moving, where before this two exhibition of K-Fair happens only 3 years once. And for the past 6 years before, majority players start to talk about biodegradable, degradable plastic, compostable, and etc. All this new material. And during that time, I believe the market is not really ready due to the pricing is way much different. And as at today, there are some product and material that can be very competitive. And later on, I can share with you how can we make this thing happen slowly and on the application of having a green technology into our plastic product or packaging by using certain percentage and blending process. So over here, the percentage showing the market is a potential, highly potential in making, in supplying as the size is growing, and tremendously it's growing much further and much faster from the non-biodegradable material. And you can see consumer goods and automotive and packaging and others are also looking for an additional material to be add on with the current conventional material. So the way forward, I would like to introduce a bit of our material product. We call it Hijau, and there's many more. Hijau is a biodegradable resin that is sustainable from the palm oil sector. So the natural base here is being used by palm styrene, which is, I would like to share on the next page, is this one. So the world first palm styrene bioresin. Many people came to me and to us and asked, why are we using palm styrene? As we know in the market now, when talk about biodegradable or biomaterial, majority comes from cornstarch, tapioca, and sugarcane and few others. And we, as a Malaysia company, we are trying to bring on our palm oil, because palm oil is one of our biggest contribution for export market, and we want to take advantage on this. As you know, all the EU always ban palm oil, Malaysia palm oil or Indonesia palm oil, saying that we are doing deforestation, we're doing killing the orangutan and etc. So we believe that we are trying to tell the world that, look, we as a Malaysian company that is in the palm oil industry, we have an alternative. We also care about the green we are trying to create a green technology based on the palm oil. So here we are creating the world first palm styrene bioresin. And majority, most of you know that palm styrene is being used for wax and cosmetic products. So palm styrene with a proper blending, as you can see on the compostable eco chain there, the cycle on the right, from renewable resources or plant-based, the palm styrene, we combine with our polyester resin, natural fillers, and we create a pelletized bioresin. And we can produce all the finished products through all type of application. There are types of injection molding, blow molding, and also blow film. So this creates the degradability. But just to share a bit of my recent knowledge that I get from the Europe market, especially, the market is not ready to convert 100% degradability. But what we're trying to start with a percentage to grow. And this is something that I take an opportunity recent when I met Datuk Sri Johari Ghani as a Minister of Commodity. We mentioned that, look, we are trying to create a solution from the palm oil, of byproduct of all the palm oils for plastic industry. So here we are today. We are bringing one of the byproduct of palm oil into the plastic world for the new bioresin. And so far, as usual, Malaysia have challenges in terms of policy and the pushing factor on the mandatory, where all industry have to start a sustainability material in their manufacturing. So these are the products and services of application that we can apply to on bioresin. Later on, the next slide, there will be more, not only from the palm oil byproduct material, there are from waste to material as well. So here to show all of you that blow molding can be processed with our resin, injection molding for all the cutleries, the cosmetic bottles, ketchup bottles, and the film. Film extrusion for the agriculture. Malaysia have quite a broad of industry into agriculture, and all the plastic mulch we are converting into a sustainability material. So film extrusion, and we also can do our pelletizing. On top of that, just to share with all of you, we also can do an OEM, where our recent technology that we find is turning waste to wealth. So this coffee idea, from a coffee waste into a new material that can be used for all this application, as you can see on the picture. At the moment, we have a proven products that been produced by coffee waste is coffee capsules and a bit of cups and cutleries. So from waste to wealth into a sustainable future. So this is something that we are collaborating with our US client in Arizona, where they are a coffee manufacturer. They are making all the coffee pots. They have their coffee brands and coffee machines. So we take the opportunity as a Malaysian company, which we love to cook at our lab. And we are crazy people that have many ideas, trying to be too much innovation, And so with Ijau elements in this coffee waste material, from the coffee pot, we dry process it and we convert it into a new pelletized with our extrusion machine, and we finally made it. The eco pellets are then delivered to our partners and clients, who they can produce for coffee pellets, coffee pots or cutleries, and etc. So this is one of the solution as well, besides using a palm oil for our company, where we find that there are many ways also that we can being reproduced for a new material. So it is compostable, is degradable as well, and the most importantly is renewable. So another technology that I would like to share is a plasticizer. So plasticizer is also a palm oil based plasticizer. This is very focused on the application. Plasticizer is towards cling wrap, plastic food containers. It's mainly for the FMCG, for the children toys and all the rubber products. So plasticizer is a liquid form where this liquid form it can be replaced for the DOP and other types of crude oil-based processing aids. And by far, mostly Korea or Japan is into this type of material, because I can say among of all our products, this is somehow very competitive in the price of sustainability material. And we managed to expand our product to Korea for this plasticizer. So the price is competitive. It's switching to BPP from DOP, DINMP in a cost efficiency way. And yet again, when we all talk about green technology material, it's always there's a roadblock. The biggest roadblock is always about the price. How can we compete with the current thermoplastic or material that we have in the market for manufacturers to apply? Another idea, not an idea, this was an idea from our client that provide us to create the R&D, and we turn it into a reality where from a used fishing net, we begin to source fishing net. It's an abundant product, but it's not easy for us to really, there's a bottleneck for this product, but it's an idea that to say that from the fishing net, we shredded it into the process and we pelletize it, combined with our natural fillers, and the application is so far is for all the pictures that have been used. It has a nylon component or property. So these are the items that we can produce. So these are a circular economy that we are looking for. And we believe Malaysia have a lot of potential in terms of renewable products, or circular economy from waste into a product. But part of the challenges when it comes to becoming a green technology material supplier, it's regulations. Before we go further to Europe or Japan or India or even US, even our current government, we are trying to work with SIRIM to get this My Hijau certification, which we are ongoing together with Ministry of Science and Technology. So when we found out there's an opportunity for us to export our local material to outside, these are the product and services and certificate that we have to comply to. I'll give you an example. In Japan, we were at Osaka for the expo for week 22 together with NRES, which is Kementerian Kementerian Environment. So at Japan, there's some certification that we have to apply for us to supply. So these are just a general knowledge for all of you that every country have their own regulation that we have to comply in terms of green sustainability related material. So of course, when we are doing a high impact, there's come a high return of the investment that we have put into on our development of material, and we are expanding our market demand and putting ourselves in as a leader that producing a variety of sustainability material. So that will be all from me. I also want to take this opportunity to say thank you for the opportunity to share a bit about what does our company do, and we look forward to hear from all of you. We are searching for a collaborator. If there's anyone that is interested to know more, by all means, you can have all these details and contact us to be part of this journey together. I believe we can't do this alone. That is why we are very humbled to be part of this MPMA program to share that we as a Malaysian, we have to find ways towards 2030, what are the solutions in terms of our plastic industry. So thank you very much, everyone.
Thank you, Mr. Q.
Yeah.
Yeah, so there is a few questions from the chat box. The first one is biodegradable versus recyclability. How does pump stream bioresin fit in? Meaning, how does it work entry the plastic recycling system?
Okay, Mr. Jurgen, Your question, okay, when we know about recycling, right, the process of the recycling system, plastic, even recycling have their own type of process, you know, and we know that we know that even biodegradable, it is not something. The common knowledge that we know is that when we just put it on the land, when they have the typical three element, water, some microorganism, land, and sun, all this, they will degrade by itself over the period of time. But we believe when we find out and we go detail that even so is a biodegradability that using palm styrene into a bioresin and etc. We believe it has its own process as well in degrading it, besides just leaving it on the sea, in the sea, or and etc. So to me, that is how we are trying to accommodate the recycling market, and as well to also to see how is an additional option for the industry to use beside recycled material.
Okay, I think the second and the third question is linked to each other. It sounds like this, How about for strain? That means EJAL resin used for strain for medical application. And normally for strain is made by PP. So the question is the quality of EJAL resin is the same as PP?
Yep. Okay. So to answer to Muhammad Rushdi, we identify that when it comes to a medical product, the certification or regulation is much more higher. And recent technology that we had with a Korean, we love to work with. We recently worked with a lot of Korean companies, and there is a Korean technology that's trying to work with us at the moment, that we can turn the quality is the same as the PP with the current PP. It's just that we are, of course, again, in terms of quality, in terms of the usage of it, is the same as the current thermoplastic. It's just that when it comes to cost to be implemented, that is where the most challenges part. So despite medical or non-medical product, we can do, provided following the requirement to apply on medical and etc. So we have a variety of certification that we can also look into medical, and we are trying to work on with FDA as well at the moment for us to supply to some medical clients abroad with our material.
Of course, to my understanding, for medical application, one of the crucial criteria is sterilization.
Yes, the clean room.
So I'm not sure whether EJAL comply with the sterilization process.
Yeah.
So the next.
Just to add on, Mr. Allen, to add on, maybe I forgot or missed to say something here, is that you see, when it comes to degradability or sustainability material, most of big companies, when I go to exhibition, most of big companies, they're just doing blending. It's just a blending process, and what is the most crucial question that we always like to ask: what is the natural base or the plant base that you're using when you want to say is a sustainability, right? So like us, the plant base that we hold on is palm oil, the byproduct of palm oil. And some I give you an example. Braskem, Brazil company, is a big company. They're using sugarcane, and majority of the implementation of the material inside their product packaging that they are supplying is only maximum up to 30%. 30%. Meaning, with the current convenient manufacturing that we are using, we have to just add on some percentage into the formulation of producing our current products. And by all means, we can claim it as a green product. Nothing is easy to just change 100%, but majority in Europe or even in Asian, I see that those big companies, they add on percentage by percentage. This is something that we are trying to do our in-house and of course to our country as well, especially to plastic manufacturing.
Okay. I think the next question is referring to the end products using e-gel resin to produce, how the biodegradable process need any special process or external element, to make the biodegradable process happen. And then
Yeah.
whether e-gel have serum eco label. Yeah. That's
Yeah. Okay.
this is
So yes, we eco label certified for e-gel, of course. As I mentioned earlier, we are also working with Ministry of Science and Technology for our material. And the biodegradable process, it can be tuned or custom by the demand that we get. I give you an example. I believe we all tried the 7-Eleven plastic bag before, where when you put 1.5 liter bottles, 2-3 bottles, and it just koyak, immediately. So there are many types of people claiming degradable, but it's actually a oxo plastic or oxo material that still produce microplastics. But yes, biodegradable process, there is its own process if we want to throw it out and etc. But at the same time, it is as normal as any other plastic. The way of reusing a degradable or bioplastic is the same as the current plastic. It's just that we are reducing the lifetime of its the lifespan of it's gonna be degraded. I can tell you some product we can make it at 6 months to be degraded. Some product it takes 6 years or 600 years to be degraded. So these are can be tuned upon formulation and additive towards that particular material.
okay.
Yes. Is there any?
There's a question asking Gaia to share the company profile later.
Of course.
Anyway,
Yes.
I have a question for you regarding the e-gel plasticizer. Just now you mentioned something like replacing DOP, but I don't know how is the plasticizing effect between e-gel plasticizer and DOP. Is it same? Or
Yeah. So the former the performs the same or better than the DOP and the NMP. And again, we can tune towards the application of that particular manufacturer. So to answer your question, yes, it can be better, or it can replace the current DOP and the NMP.
okay. In terms of dosage in the formulation, can it be replaced 1-to-1?
Yes, it can be replaced 1-to-1.
Okay.
Yes.
Okay, I have no more questions. Any question from the participants? Any more? Okay, if no, then I will hand over back to MC Francis.
Thank you, Alan. Thank you, Encik
Alright.
Is it Qayyum? Qayyum, am I saying it correctly?
Yeah, you can. Yeah, I mean that's why.
Qayyum.
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 Okay.
Okay,
Thank you so much.
Thank you, Encik Q. I also want to thank Sato-san and Dr. Shamsul for your excellent presentations this morning. Encik Q, that last question on your company profile, can you try and place it in the Q&A box? Can you try and do that?
I'll try to do that.
Okay, thank you.
Yeah.
Okay, you try and do that. Okay, in the meantime, we'll carry on. Once again, thank you to all our speakers and Mr. Allen for your wonderful moderation of the session. We would now like to do a quick poll to assess the webinar, and this is to help MPMA understand the areas of improvement for future webinars and events. Kindly participate by giving us your feedback. Can we have the poll on? Yeah, we'll put it on for about 5 minutes. It's very easy. All you got to do is just select an answer. It should be quite fast. Okay, we have so far about 30% responses. Can we have more responses to our poll, please? Can we have more responses from the attendees, please? We only got about, I think, 30 respondents, 35 respondents have replied to the poll. Can attendees please spend 5 minutes just to answer the poll? Thank you. Once again, a big thank you to everyone for being with us this morning. Mr. Alan Chong, our moderator, thank you so much. Our speakers, Dr. Shamshul, Sato-san, and Inchek Q. The next webinar is on Tuesday, 11 November, and the theme for the webinar next week is latest injection molding updates. And the session for next week will start at 2:30 p.m. Once again, thank you to everyone for being with us this morning at MPMA's Plastech. Have a pleasant rest of the day, and we look forward to seeing you at our next webinar. Thank you.